Welcome back, Math 2. All right, today we are still going to be working with proportions, but we are going to jump into a little bit more challenging stuff, unless you're a very visual person. Hopefully I can explain this well the first time, and let's just jump in, okay? We're going to learn today about a geometric mean, and we're going to learn what an altitude is. An altitude is a piece of a triangle that you probably just haven't been introduced to yet. Okay, so let's talk first. Let's get a definition of what a geometric mean is. Okay, so you've probably heard the word mean before. It's used in like statistics where a mean is an average. Okay, and you are used to the mean or the average being the thing where you add up all the numbers and divide by how many numbers there are. Okay, that's called an arithmetic average. And in geometry, we also have a geometric average or geometric mean. And in this case, what it means is that we are going to multiply in our case, two numbers, and we take the square root of that answer. Okay, this is also going to be a proportion. Okay, so I'll show you how to do it just that simple way where, okay, I'm just going to multiply two numbers, take the square root, but this is also going to be a proportion where we have an x in it twice, like so. Okay, and it'll make sense why that comes up in a little bit. Okay, so just bear with me on that. So real quick, let's do some practice. So if I wanted to know the geometric mean of 4 and 16, or the geometric average, okay, I would do 4 times 16, which is 64, and then I would do the square root of 64, which is 8. So the geometric mean of 4 and 16 is 8. Okay, I could do the same with 6 and 30. I'm going to take 6 times 30, and I would get 180. And then I would take the square root of 180, which doesn't come out equally, but we'll just use a decimal. We're not going to bother with simplifying the radical, but I get about 13.4. Okay. The other way we could set that up, which I want you to be really comfortable with, is using this proportion. So I'm going to redo that first problem using the proportion. So if I wanted to know the geometric mean of 4 and 16, I would set up a proportion where I have 4 and 16 in opposite corners because I need to make sure I multiply them when I cross multiply. And in the other two spaces, since I don't know what the geometric mean is, I put an X in both of them because I don't know what the answer is. Okay. Now, because we already know that the geometric mean is 8, let's just envision here what this proportion actually looks like. So I really have 4 over 8 equals 8 over 16. And that makes a bunch of sense because if I simplify both those fractions, it comes out to 1/2. Okay, so that's what a geometric mean is. It's how can I make these two things proportionally equal. Okay, but if I cross multiply like this, I still have 4 times 16 giving me 64. On the other side, I get x times x, which you should know is x squared. And then to get rid of an exponent of 2, I use a square root. That cancels out my exponent of 2. And I also get x equals 8. We're not going to do the positive negative thing because that doesn't apply here. Okay. So all of that process will come in handy in about like 3 minutes here, okay? So just bear with me. Let's move on to our second definition of what an altitude is. So it's a piece of the triangle, okay, that goes through one corner and is perpendicular. I'm going to use the symbol for perpendicular, which is that, to the hypotenuse. Okay, so remember the hypotenuse is that longest side. It's across from the right angle. So that means in my diagram here, this line is the altitude. It intersects that hypotenuse perpendicularly or at 90 degrees, and it goes through the corner A. What happens when we have an altitude is it ends up creating three similar triangles. I'm using a lot of shorthand today because I'm running low on space. Okay. 3 similar triangles. Sorry, I hope I'm not repeating myself, but I seem to have cut out. So what happens once we have an altitude drawn in to a triangle is we end up creating, oh my goodness, go away. Creating 3 similar triangles. I'm using a lot of shorthand today, so I hope you remember what all these symbols mean. And it's kind of like we end up having a big triangle, a medium triangle, and a small triangle. Okay? So I'm going to actually draw the 3 of them out, and we're going to see how that altitude affects everything. Okay? So my big triangle is obviously this one on the outside. I'm going to call that B, and you know what? I'm going to label that right here. BAN. Okay. Then my medium triangle, here, I'll highlight that in green, is right here. Okay. Now what's important is I need to rotate that around so that I have all the same letters going in the same way. So I'm going to turn that, because notice I started with BAN. I went from B to A. So I started on the short side of my triangle, and it ended with the right angle. So on my medium triangle, if I orient it this way, my right angle is at T. The long side takes me to N, and the short one takes me to A. So my medium triangle is ATN. And then I also have this little triangle, a small triangle, which again I'm going to orient properly. The right angle is right here again at T, but I'm not going to N. My long side actually now takes me all the way to A, and the short side takes me to B. So I have triangle BTA. Okay. All right. So what this does is it also creates a couple corollaries, and we're only going to talk about one today. So I'm going to draw a little bit of a line here. Remember, a corollary is just like a little small rule. But what happens is that the length of the altitude, that line that divides everything, ends up being equal to the geometric mean of the 2 segments or pieces of the hypotenuse. So let's talk about what that means down here. Oh, lordy. Is that really going to do a thing now? You know what? I'm going to erase this part just so I don't have to deal with these shenanigans later. Don't know why that's not moving, but okay. Oh, really? Very irritating. Sorry. Okay, so let's see what that means here. So, in my first example here, I want to make sure I know where the altitude is, and that is this one right here. So 8 is the altitude. Okay. Then it says also in the correlated that length of the altitude, so that 8, is equal to the geometric mean of the two segments or pieces of the hypotenuse. So x and 4, those are my two segments of the hypotenuse. Okay. So let's real quick move back up to the top where it says how we set up those geometric mean proportions. Because remember, it is still just a big proportion. Okay. So when we were finding the geometric mean of two numbers, we put those numbers in opposite corners, and then the geometric mean part was in the opposite two corners. Okay. So what happens is, okay, I already have my geometric mean because I have the length of the altitude. So that 8 is going to go in twice. And in the opposite two corners, I know that 8 is the geometric mean of something, that x, and 4. Okay, so whatever your altitude is should be going into this proportion twice. Okay, and I'm just going to cross multiply. So on part of it, I should have 4x. And the other, I have 8 times 8, which is 64. And I'm going to divide by 4. And I should get 16, which is what we had at the top. Remember, the geometric mean of 4 and 16 was 8. Okay, now I know, oh, the geometric mean is 8, and one of my numbers is 4, so the others is probably 16. Okay, let's try another one. Okay, this time my altitude is x. That's the number or the piece that I'm going to use twice in my proportion. So I should have an x twice. And then the two pieces or the two segments of the hypotenuse are the other two numbers, 4 and 9. And again, I'm going to cross multiply. So I'm going to have x squared on one side equals 4 times 9, which is 36. And if I square root both sides, I get that x equals 6. So my altitude in there is 6.